And here's your lesson objective for today. I'm going to show you how to convert decimal values to binary. So we're going to take a decimal number and convert it to a binary number. And while it's not necessary to take notes on this lecture, if you wish to do so, I would suggest putting them in the 1.N4 Intro to Binary Number System notes that should already be in your OneNote class notebook. All right, so let's start. The binary number system, or the base 2 number system, uses 2 digits to represent all numbers. We have 0 and 1. And using 0 and 1, we can count up to infinity. We're using 2 as our base. So here's a list with some corresponding place values for base 2. We start at 2 to the 0 power. And in my example here, I'm just going to go up to 2 to the 7th, or the 128th place. Of course, we can go farther left. We can go 2 to the 8th, 2 to the 9th. We can go 2 to the 100th, but we're not going to do that in this example because we're not going to be dealing with numbers that big. So say I want to express the decimal number 50 in binary. Well, how do I do that? Well, let me show you. Okay, in my first example, I need to convert the decimal number 50 into binary. So what I do is I take a look at that number 50. And starting from the left-hand side, I'm trying to fit this number in here. Okay, if I can, I put a 1. If I cannot, I put a 0. Essentially, I want to subtract this number from 50 and have it be positive. If I can't do that, I have to put a 0. So 0 for 128. Moving to the right, 64 is also a 0. Okay, there are no 64s in 50. Okay, that's essentially what that 0 is saying. Moving on to the right, now we have 32. I'm going to put a 1 in the 32's place. And now I'm going to subtract 32 from 50. I'm going to find my remainder, 18. And now moving forward, I'm only looking at this 18 now. I'm not looking at the 50, the original number. I'm now looking at the remainder of 50 minus 32, which is 18. So moving forward to the right, I'm going to put a 1 in the 16th place because there is a 16. Subtract that number, and my remainder is 2. Again, I'm just looking at the remainder now as I move to the right. I can't fit any 8s in there. I can't fit any 4s, but I can fit a 2, so I'm going to put a 1 there. I'm going to subtract that. And what we're hoping for is a remainder of 0. If you did it correct, you should have a remainder of 0. Okay? Now, to check my work, what I can do is I could say 32 plus 16 plus 2. 6 and 2 is 8, plus 2 is 10. Put a 0 here, carry the 1. 3 plus 1 is 4, plus 1 is 5, 50. Okay, so 50 in decimal is equal to 1101010 in binary. I hope that makes sense. If it doesn't, I'm going to do another example here. Okay, in my next example, I want to convert 75 decimal to binary. Okay, so again, I'm looking at the number 75, and starting from the left-hand side, I'm trying to see if I can fit this number into 75. Well, I can't because it's 128. It's too big. So I put a 0 in the 128's place. However, as I move to the right, to the 64's place, I can fit one of those. So I put a 1 in the 64's place. I subtract that value from my original number of 75, and I get 11. So now I'm looking only at my remainder number, okay, as I move to the right. So I'm going to put a 0 for 32 because that's too big, as is 16. However, I could fit an 8 in there, right? So I put a 1 in the 8's place. I'm going to subtract 8. And I get 3. So moving along to the right, here's the 4's place. That's a big number. That's too big. But I could fit a 2 in there. So I put a 1 in the 2's place. I subtract that from 3. And lastly, I put a 1 in the 1's place. And now my remainder is 0. Okay, so checking my work, I can say 64. I'm writing with my mouse, so I apologize if it's brutally slow. 8, 2, Oh, I forgot my 1 in there. 8 and 2 is 10, plus 4 is 14, plus 1 is 15, so leave a 5, carry a 1, and 6 and 1 is 7, 75. Okay, so my answer checks out. So 75 in decimal is equal to 1001011 in binary. Now I'm going to go the other way. I'm going to go from binary to decimal, and you're going to see it's the same exact concept. It's just flipping those things. So check this out. Okay, my next problem is 11001 in binary is equal to blank in decimal. So what I do is I fill in this binary value into my chart. Okay, 1, 2, 3, 4, 5. It's 5 digits or 5 bits. 1, 2, 3, 4, 5. That's too much. 1, 2, 3, 4, 5. Okay, so we go 1, 1, 0, 0, 1. You got to make sure that this rightmost bit is in the ones place, okay? Because if you don't and you put it over here, if you start maybe in the 32s place, it obviously is going to change your value, okay? So now what we have to do is add up the values where the ones are. So we need to add 16, 8, and 1, okay? So 8 and 6 is 14, plus 1 is 15. Carry the 1. 25. So 11001 in binary is equal to 25 in decimal. Okay, moving along, 111111. Okay, so 111111. We have to add all the values where these ones are. So 32 plus 16 plus 8 plus 4, 2, and 1. My answer is 63. Okay, hopefully this makes sense and will help you with your next few assignments. If you guys have any questions, please feel free to ask me. This is Westfall signing out. Peace out, as the Canadians would say.